guys, today we are going to be introducing our second technique as to how to graph the equation of a line. Okay, but before we do, I'm going to give you the graph of an actual equation, and then I'm going to ask you to identify some information. So we have the graph of this equation, negative 2x minus 3y equals 6, and the question is what are the intercepts of the line? Okay, so intercepts, we have two intercepts. The first one is the x-intercept, and the second one is the y-intercept. What is x-intercept? The x-intercept is the point where the line intercepts the x-axis. So in this case, the line intercepts the x-axis at negative 3. So if the line intercepts the x-axis at negative 3, then we're going to tell the world that the x-intercept, we're going to use our made-up abbreviation, the x-intercept is at negative 3. Okay, so please speak to your instructor in terms of the notation. I'm okay if you just put x-intercept equals negative 3, but if I follow straight definition, x-intercept, point, it's ordered pair. Okay, so as an ordered pair, it should be where am I? Negative 3, 0. Okay, so again, check with your instructor. All right, so we have two axes, so one intercept down, one more to go. Y-intercept, what is that? Y-intercept, point where the line intercepts the y-axis. So in this case, the line intercepts the y-axis at negative 2. So we're going to tell the world, the y-intercept is at negative 2. So again, you can just give me the number itself, or again, you may be required to write the ordered pair. So x is 0, so and y is negative 2. So as an ordered pair, it will be 0, negative 2. Cool. Now, are you going to see this problem on the test? Of course not. Okay. You're going to be given the equation, a blank graph area, and then you're going to have to graph the line. Okay. So it says use the x-intercept and y-intercept to graph the equation. Okay. So we are not given the liberty to graph this equation however we like. We have to use the x-intercept and the y-intercept. So let's go ahead, find the x and y-intercept, and then we utilize them to graph the line. So now the question is, which intercept should you find first? It doesn't really matter. I like to do things in alphabetical order. Yeah. So we're going to find the x-intercept first. So the question is, how are we going to find it? So I'm going to go ahead, open up the book, and the book says let y equals 0 and solve for x. Let y equals 0 and solve for x. And the question is, why is it that we have to let the other guy equal 0? Well, that just comes from the graph. Okay, x-intercept, point where the line intercepts the x-axis. It doesn't matter where I am on the x-axis. If I'm right here, y is 0. If I'm right here, y is 0. Anywhere on the x-axis, the value of y equals 0. So it comes from math. Okay, so you are really good about plugging and chugging, but I'm not. Anytime I'm going to substitute a number for a variable, I always write down my equation or whatever I'm dealing with. Okay, equation or expression. In this case, equation. So what are we going to do? We're going to let y equals 0 and solve for x. So we have 5 times x plus 2 times y, which we said is 0, equals negative 10. Fantastic. Okay, so keep your cool and go ahead, solve for x. Product of 2 and 0 is 0, and that will leave us with 5x is equal to negative 10. For the grand finale, to get rid of the times 5, let's go ahead, divide both sides by 5. And that will give us x equals negative 2. Perfect. Okay, but when we write x equals negative 2, that doesn't translate that the x-intercept is at negative 2. That's just saying some x value is negative 2. But look, you just put a dash int, and it's like, bam, oh, the intercept, the x-intercept is negative 2. So if the x-intercept is negative 2, then the graph should intercept the x-axis at negative 2. So let's go ahead, leave our mark. Cool. So one intercept down, one more to go. So y-intercept, what is that? Y-intercept, point where the line intercepts the y-axis. So how do I find the y-intercept? You guessed it. We're going to let the other guy equal 0 and solve for y. So we're going to let x equal 0 and solve for y. Fantastic. So let's go ahead, write down the equation. Do you have to? No, but whenever I don't write down the equation or expression, I make silly mistakes. So let's substitute a 0 for x and then solve for y. So we have 5 times x, which we said is 0, plus 2 times y equals -10. Product of 5 and 0 is 0, and that will leave us with 2y is equal to -10. For the grand finale, to isolate the y, to get rid of the times 2, let's go ahead, divide both sides by 2, and that will give us y equals -5. But again, if you show me this and at random, and you write y equals -5, this doesn't translate to the y-intercept equals -5. So that just means some y equals -5. But again, you put y in, and it's like, bam, okay, the y-intercept is at -5. So if the y-intercept is at -5, then the graph should intercept the y-axis at -5. Let's go ahead and locate that. Cool. So remember, no matter what technique you use to graph the line, you just need 2 points. We got 2 points. We have a straight edge. Let's go ahead, graph these so we can get our full credit. So the directions were, sorry, I extended it too long. The directions were use the x-intercept and y-intercept to graph the equation. We took the x-intercept, we took the y-intercept. Yeah, we used them to graph the equation. So, cool, we did it. Thanks, guys.